Hello everybody. Today I am going to start a new chapter, estimation of motor power rating. In this chapter, we will discuss different issues in modeling of machine. Thermal modeling of the machine we will discuss. To reduce the complexity of the system, we will assume some parameters. Estimation of motor ratings. Here, first of all, I want to discuss that why this estimation of motor rating is so important. When we are going to develop a drive system to run a load, our main motive behind it is that our drive system must be efficient and economical. Now, we have to run a load. Now, to run that load, what will be the optimized size of the motor? We have to decide. Then we have to find the different insulating materials for that motor. To find that, we have to model this complete motor system. Thermal modeling of the motor is to be done. Key issues associated with estimation. First of all, we know that when our most popular motors, induction and synchronous motors, operate at a power less than its rating, then the input power factor becomes 0. Because of that, current drawn from the source consists of lots of harmonics. Efficiency of the system reduces. Complete behavior of the system is changed, or the system becomes costlier, filtering requirement will increase. So those issues are there. So our induction motor and synchronous motor must operate close to its rating. Next point, whenever a motor operates, heat is produced due to losses inside the machine. Now we are familiar that different types of losses across the system are core loss, copper loss, friction loss. Due to this, temperature of the machine increases. Now whenever the temperature of the machine is more than the surrounding temperature, then heat will be dissipated to the atmosphere to cool the system or to achieve the equilibrium state. So we can say that there is a direct relationship between temperature and output power of the machine, and this is known as thermal loading on the machine. We will discuss as the time passes. Now, one of the most important issues in estimating this motor power rating is that temperature of different parts of the machine is not constant. The reason behind it is that some parts of the machines are exposed to the atmosphere, some parts of the machine are insulated. Because of that, temperature throughout the part of the machine is not same. So it is one of the major issues in estimating the power rating. Let's discuss the first point with the help of an example. Suppose we are going to select a motor. Now the motor is connected to a load. There may be the case that load torque requirement is more than the torque developed by the motor. In that case, motor will try to cope up with that load. Then motor will draw more amount of current from the source. Because of that current, I square R loss will be there in the motor. Then temperature of the motor will increase. Now different insulating materials are placed across the motor. Now if the increase in temperature is more than the withstanding capability of the insulating material, then the insulation will break down. Because of that, there will be a dead short circuit across the windings, or some other unwanted behavior of the machine we will see. So it should be ensured that temperature should never exceed the prescribed limit of the insulating material. Now there are various loads which operates at constant power and speed, but at the same time nowadays variable speed drives or adjustable speed drives, or you can say variable power, variable speed drives are becoming too much popular. A straightforward relationship is there in case constant power and constant speed operation is there, but the complexity increases if the load is variable or the power is variable. So this is one of the major issues nowadays we are facing to model a machine. Now accurate prediction of heat flow, it is almost impossible because the temperature throughout the body of the machine is not constant. Some parts of the machines good cooling system is there, some parts of the machine insulated, some parts exposed to the atmosphere. So heat dissipated through different parts of the machine is not constant. Because of that, it becomes very tough to model that machine. So that point is here. An accurate prediction of effluent temperature rise inside an electrical motor is very difficult due to complex geometrical shapes and use of heterogeneous materials. Here what we will do, we will use approximation method. We will assume that complete motor is a homogeneous system. Same temperature is there across different parts of the machine. Then we will model that one. In later classes we will see. In electrical system, insulating materials played a very important role. It is required to isolate two current carrying paths, or from dead short circuit we want to avoid. In between the path we have to keep insulator. Now different insulating materials have different temperature withstanding capability. Based on that, different classes of insulating materials have been developed. Now those classes are gamma, A, E, B, F, H, based on the different temperature withstanding capability. Suppose for low motors or low size motors up to 90 degrees centigrade, if you want to withstand, then you can use silk, cotton, natural rubber, etc. as insulating medium. But for large size motors where temperature withstanding requirement is around 180 degrees centigrade, then we have to choose some other materials like silicon elastomers, etc. So based on our temperature requirement, we will use different types of materials in different cases. From next class, I will start thermal modeling of machines. In that class, we will assume some parameters to reduce the complexity of the system.